Welcome to JAMA Plus AI Conversations. I'm Roy Perlis, Editor-in-Chief of JAMA Plus AI, and my guest today is Dr. Daniel Lindsay from QIMR in Queensland. Today we'll be discussing his recent study, Cost-Effectiveness Analysis of 3D Total Body Photography for People at High Risk of Melanoma, published in JAMA Dermatology. Dr. Lindsay, thanks for joining us today.
Thank you. Thanks for having me.
Absolutely. So, before we get into the specifics, could you give us a little bit of clinical context? What is 3D total body photography and sequential digital dermoscopy, and what's sort of the standard application in melanoma screening?
So 3D total body photography, in this instance, in the study that we looked at, was done using the Vectra system, which basically takes 92 cameras and takes simultaneous images, which allows the creation of a 3D avatar of pretty much the entire skin surface. So that's your 3D total body photography. And what that allows is for the identification of lesions using computer software, because all those images get uploaded. And so in terms of the sequential digital dermoscopy imaging, so that is basically just dermoscopy, but done over time to identify changes in lesions, which help to guide the decisions for clinicians around whether it should be excised, left alone, whether it's benign, melanoma. So yeah, that's those two concepts.
And just so we can get our minds around the technology, this is a device that sits in a dermatologist's office. Like, what does it actually look like? How long does it take? What is it?
Yeah, so what it looks like, it's quite large actually. So it would fill basically a whole room, so a whole sort of clinician's room. And individuals, I guess, if you think about airport scanners, where people go in and they stand with their arms sort of raised outwards, and then the images are taken of that individual, again, of their whole body. So it is quite a large machine. So the photos are taken quite quickly. So I think within a matter of minutes, and then the uploading of images, again, it takes probably, about 10 minutes. And so I guess an appointment could take around half an hour to an hour using this machine and getting all of the images uploaded and ready to be analyzed by the clinician.
Got it. And the randomized trial compared this technology to usual care. So it would be helpful for you to say a word or two about what did usual care look like in the study?
Yes, and I think that's probably where I should put some context around. This was done in Australia and Brisbane, which is notoriously quite high in terms of its skin cancer rates. So within Australia, a lot of skin cancer screening and diagnostics is done by primary care physicians here, so general practitioners. So a usual care episode could include anything from 2D total body photography to 3D total body photography isn't used in clinical practice just yet. It's still sort of at the research stage. But a lot of dermoscopy, a lot of clinicians who are trained in the use of dermoscopy. So that's usually a full skin examination. And these are encouraged for high-risk individuals every 6 months in Australia. So there is a lot of this happening in the country.
Got it. One of the things that you mentioned, primary care, one of the things that I thought was interesting in the study is that it involves junior clinicians and teledermatologists. What was the rationale behind that staffing approach? Why'd you do it that way?
Yes, good question. And this is one of, I guess, the issues that we raised with our study is that we did use these junior teledermatologists to have a look at the initial lesions or suspicious lesions that were taken from the 3D total body photography. And so I think that the purpose for this was, clinician time. I think getting individuals involved in the study as actual, registered clinicians, not just junior clinicians, I think would have been difficult to obtain. We're obviously hoping that we can do that in the future because we're hoping that this technology can be rolled out in clinical practice. So I think in terms of the setup of the RCT, I wasn't actually involved in that, so I can't say too much about why that particular approach was taken.
Got it. And this is probably a good time for me to point out that we're here to talk about the cost effectiveness part, because while the technology is cool and I think it's important to do these kinds of RCTs, I was really intrigued by the result of the cost effectiveness study. So maybe you can say a word or two about that. What was the punchline?
Yeah, so just again, some context. I'm a health economist. So we sort of come in at the back end once these trials have been completed to look at the cost effectiveness. So essentially, again, just for the listeners, cost effectiveness basically compares two or multiple interventions to assess the cost benefit of one intervention over the other. So obviously here we looked at the use of 3D total body photography versus the usual care approach, as you've already identified. So we thought it was really important not just to look at the clinical outcomes related to 3D total body photography, but also the economic because we know that these technologies are quite costly and they haven't been analyzed from a cost effectiveness perspective beforehand. So we wanted to come in and use the trial data and the clinical outcomes in order to determine the cost effectiveness of this technology.
And I should point out here that the reason I keep calling it the technology is that I think saying 3D total body photography is too much of a mouthful. So I just want to underscore that. What was the punchline?
Yeah, so the main findings, I guess, of the paper, and these were things which surprised us a little bit here, was, I mean, if I talk about clinical outcomes first, what we found was that the intervention group, so those who used the 3D total body photography, and it's also with sequential digital dermoscopy imaging, so it is quite a mouthful. So that technology, the intervention group had fewer melanoma excisions, more keratinocyte carcinoma excisions, and benign excisions, more biopsies and more pathology services than control. So basically the opposite to what we were expecting and what we hypothesized. So from a cost perspective, what that meant is that we had a very, I guess that impacted the cost effectiveness profile of the technology. And we actually found that 3D total body photography compared to usual care in this particular way that we ran it had a 0% likelihood of being cost effective from a government and total healthcare cost perspective, and quite a low likelihood as well when we considered individual costs.
And despite the difference in costs, the utility side of this, the quality adjusted life years, as I recall, were quite similar between the two groups. Is that a surprise given that seemed like the treatment as usual worked better?
Yeah, good question again. So we've done a fair bit of research into, and that's the health economics team, which was previously at QIMR. We've done a fair bit of research into looking at health utilities for melanoma patients. And what we find is that health utility isn't impacted that significantly by a melanoma diagnosis. So these individuals that were in the study were only those at high risk of melanoma, so they're not necessarily were diagnosed with melanoma. There was only, say, 30 odd melanomas actually excised in the study. So it's not overly surprising that quality of life wasn't that impacted between the two. And we do make a point in our conclusion of the paper that perhaps quality adjusted life years or quality of life is not the best indicator to separate people who do and do not have melanoma, which is actually quite an interesting finding. But again, it's, I guess, that the burden of a melanoma, particularly when we're looking at high levels of in situ melanomas, perhaps isn't as great and well captured on these particular measures.
So I think you just made an important point, which is presumably a lot of these are the sort of early non-metastatic kind of melanomas, because naively sitting here listening to you, I would think they would make a huge difference in terms of qualities.
Yeah. Yes, absolutely. And when you think about metastatic melanoma, obviously that would have a significant impact on quality of life. Sorry, that just to clarify that. But what we see in Australia is a lot of these in situ early stage melanomas. And look, I think in terms of the capturing of melanomas on our 3D total body photography, we're hoping that we can catch, melanomas before they get to that advanced stage. And that is one of the things that is a primary goal, is the early detection of melanomas, so that we don't have to worry about those individuals getting those advanced melanomas, which are, from a health economic perspective, obviously it has poorer clinical outcomes, but from a cost perspective, these are much more costly because of the therapies which are required to manage those more advanced melanomas.
So let me push that a little. In the US, a payer would look at this study and say, absolutely not. We're not going to pay for this 3D total body photography and sequential digital dermoscopy. A, is it different where you are? And B, would you interpret the study differently? Or maybe put another way, how would you push back on the payers, or would you
Yep.
push back on the payers?
Yes. Look, in terms of the cost effectiveness, we have identified at this point, in the way that it was delivered with these junior clinicians and with the teledermatologist review, it's perhaps not the best approach for actually putting this technology into a clinical pathway. And so I think what we are arguing here is that, again, the way that we did it in our study, not the most cost effective method. So let's look at new methods or different methods of how we can actually apply this technology into clinical practice in order to make it cost effective. And so what can we do to actually do that? What parameters can we change? What clinical pathways can we look at and alter in order to make it cost effective? And so I guess what we want to say here is that this study's result shouldn't be seen as a, let's ditch this technology completely. I think what we want to see is how can we improve it? And I think relevant to this podcast, one of the ways is through artificial intelligence.
So say more about that. Where would you insert AI into this process, and what do you think the benefits likely to be?
Yep. So within the 3D total body photography technology, there is inbuilt artificial intelligence into that. And so for this study, because that artificial intelligence isn't advanced enough to actually be recognized as ready for clinical practice, they turned it off for the trial. So it wasn't used in terms of classification of lesions. So what we want to be able to do is get that AI to a level where it's able to distinguish between things which are, so if it's a suspicious lesion, we can identify that it is a melanoma. And so that particular lesion should be removed. So it's for lesion scrutiny.
So that's interesting. So for this trial, even though the AI capacity was sort of in there, it was actually turned off.
Correct. So there is a lot of developments with AI at the moment. And so there's a lot happening within Brisbane as well, Queensland, where I am. So the University of Queensland is doing a lot of work to classify or build a foundational AI model to actually, get better at detecting what should and shouldn't be removed. Because from a cost perspective, anything that's suspicious and is excised is a cost. And so when you get better at looking for things and identifying things, such as what you will with 3D total body photography, because you're now getting this full image of an individual, the more likely you are to excise things because you're going to find stuff. And so from a cost perspective, that's obviously comes at a cost to the individual, to the healthcare system. So what we want to be able to do is get better at not just identifying, but then being able to say, well, we shouldn't or we should excise that because it looks like it is a melanoma.
I think this raises a question in my mind, and I'd love to know, as a health economist, how you think about this. We often talk to people who are developing these new AI methods, and the technology moves quickly, right? So you build something into a device like this, and a year later, there's a better version. How in the world are we going to understand cost effectiveness when the models themselves are this moving target? I wonder if you have any ideas about how we should be thinking about that.
Yeah, you've really hit the nail on the head in terms of the difficulties. So in terms of health economics, we have, I guess, an approach which, so the Cheers checklist, it's called, which basically looks at economic evaluations and sees whether it actually, fits the certain criteria that would actually be required of an economic evaluation. And so recently, there's been the release of what's called the Cheers AI. So basically, it's this adapted version to evaluate artificial intelligence interventions. And there is literally a paper that states that we are looking at the tortoise and the cheetah, where the cheetah is the development of artificial intelligence and the tortoise is the development of economic evaluation. So being able to keep up with all of this AI and the implementation of AI for economic evaluation is really difficult. And to be honest, there isn't a clear way to actually evaluate artificial intelligence interventions properly just yet. Some systematic reviews have looked at what's been done, and there are some glaring omissions and modeling approaches which haven't even been looked at. So I don't have a great answer for you, but you've raised definitely a big question around how we continue to evaluate these AI technologies. And this is a problem that I'm going to have because I need to look at evaluating AI when it's integrated into total body photography.
Well, once you figure it out, we will have you back on the show and you can explain it to us.
Yes.
I want to thank Dr. Lindsay for talking to us today about his study on the cost effectiveness of digital technologies for melanoma detection. To our listeners, if you want to read more about this study, you can find a link to the article in the episode description. To follow this and other JAMA Network podcasts, visit us online at jamanetworkaudio.com or search for JAMA Network wherever you get your podcasts. This episode was produced by Daniel Morrow at the JAMA Network. Thanks for joining us, and we'll see you next time.
This content is protected by copyright by the American Medical Association with all rights reserved, including those for text and data mining, AI training, and similar technologies.